Okay, so let's get our head back on Earth for a minute here and get back to the practical. How do we do this? Um, so let's start by talking about the different types of synthesis. Okay, and then we're going to go into the different elements of all synthesizers. But there's a whole bunch of different types of synthesis, maybe like 10 if you get into some of the weirder ones. But there's only 5 or so that we regularly deal with in live. So let me just kind of explain the different ways that synthesis can work. So when we talk about different types of synthesis, what we're talking about is different ways of combining sounds to make new sounds. So first, we might have something called additive synthesis. So additive synthesis is quite simple. We take a sound, we take another sound, maybe a third sound, we add them together, and that makes a sound we like. In some of the other classes in this series, I was doing things like layering different sounds, different synthesis. That's basically additive synthesis. It's very simple, relatively. Now, additive synthesis isn't something that we use a whole bunch. It's not a very popular kind of synthesis, maybe because it's simple, maybe because it doesn't result in usually really compelling stuff. But subtractive synthesis is probably the most common type of synthesis that we use on an everyday basis, debatably. Subtractive synthesis means that you're going to start with a very complex waveform, which, when I say complex waveform, all that really means is that we've got something with a lot of overtones. It's very bright and buzzy. That means it's got a lot of crazy overtones. So we're going to start with something like that, and then we're going to use something called filters to chip away at it and take away the sounds that we don't want, and then we're left with the sounds that we do want. That's called subtractive synthesis. There's another kind of synthesis called FM synthesis. This has like a kind of a distinctive sound, but FM is a different way of doing things. And one way I like to describe FM, which is a vast oversimplification, but a simplified way of looking at it, is instead of taking two sounds and adding them together like we do with additive synthesis, it's more like taking two sounds and multiplying them together and getting a new sound. So we end up with one sound, but it's based on several sounds multiplying, or modulating is a more accurate term, to make something new. Physical modeling is another kind of synthesis, and that's a kind of a whole different animal. In physical modeling, what we have is this big, long, crazy math algorithm that tries to replicate the physical world, and we can get in on that and change different parameters. So you might have an algorithm that says, here's a physical model of a violin, and there's ways to control the pressure you're putting on the string, the pressure on the bow, how many hairs are on the bow, what the humidity is outside, everything that's going to affect the sound of that. Now, physical models can be really complex, but when we use them in something like live, we have fairly simple tools that deal with all that math for us. It's not like we get this huge algorithm and we have to plug in numbers. It's not like that at all. We get a slick interface that lets us adjust things. Last one I'll talk about just as an introduction is wavetable synthesis. This is probably the most complex sounding. And what we basically have here is a whole bunch of different sounds. And then when we play one, the software kind of scrubs through all these different sounds so that it makes a new sound by scrubbing through a whole bunch of other sounds. If you imagine like those big gnarly bass sounds that you get in dubstep and things like that, they're like that stuff. That's very wavetable. If you've used a very popular synthesizer called Serum, that's wavetable. Live does have a built-in wavetable synthesizer. It's called Wavetable, and we will be looking at how to use that shortly. So just a quick overview of a couple different kinds of synthesis that we have access to. Now let's go in and talk about the different elements of all synthesizers. So here's what I have here. I have a new track, a new MIDI track, and on that track, I put an analog instrument. Now I just drug the analog instrument onto here, which means we have the default patch. I didn't load any preset. This is just the default analog patch. It sounds like this. Okay, and we're just going to work with that for a minute. So I like talking about these different elements of the synthesizer with analog because it just kind of lays them out really easy. So I'm going to use this as an example. But remember, the point here is that after I point these out, we should be able to find these on any kind of synthesizer. Okay, so we're not just going to learn analog. We're going to learn how to learn synthesis, if that makes sense. Okay, all right. So first, the oscillator section. Every synthesizer has an oscillator section. They might not call it the oscillator section, but they have an oscillator section. Now in analog, it's this. And we actually have two of them. You can see OSC1 and OSC2. Okay, there are these two things. Okay, so what is an oscillator section? Oscillators are the only part of a synthesizer that actually make sound. Everything else is about sculpting that sound. So the oscillators are units that actually like oscillate and they make sound. So we can say make a waveform that is a sine wave, and it's going to oscillate and make a sine wave like this, because that's what sine waves do. Or we can say make a triangle wave, and it's going to go. That's what triangle waves do, sort of. We can tell it what kind of wave to make, and then it's going to just start going and generating that wave. So right now, we have oscillator 1 is set up to make this shape of a wave. That's called a sawtooth wave. And oscillator 2 is set up to make a sawtooth wave. Okay, they're both making a sawtooth wave. Now, also in the oscillator section, in addition to the wave type, and I'll talk more about wave types in a second, we have tuning. Okay, so we can set the tuning to do different stuff: octave, semi, and detune. Now, these won't look the same in all synthesizers, but you'll usually have some kind of tuning parameters. So octave means like big jumps away from each other. Okay, so here's an octave, here's a note, here's one octave up. Let me turn off oscillator 2. Okay, here's just oscillator 1. Octave up. So you can think about an octave as like the register that we're in, lower, high, and a couple in between. Semi is semitone. That's every note on a piano if you look at it. White notes and black notes. There are 12 of these for one octave. Okay, so if you go up 12, let's do it. 12. And then I go down to 0, but up 12 here. It's going to sound the same. Okay, so 12 semitones per octave. Detune is cents. This is like very, very, very fine amount of space. There are 100 of these per one of these. Okay, so with these, you're not even going to hear it at first. Okay, so the numbers here are a little confusing. So I think what we're seeing is 1 would be one semitone. So we're going up by percentages of a semitone. We can go all the way up to 3. Okay, so that's our tuning. Now let's talk a little bit more about oscillator shapes. Okay, because the oscillator is the only sound making thing, it's important to understand the different shapes that we have available. Now, not all instruments have the same shapes. There are 4 really standard ones that almost all instruments will have. And then some instruments have different and wacky ones. But let's look at those 4 first. So I'm going to switch over to a program called Audacity. Maybe you've heard of Audacity. This is a free program that you can find online if you just search for it. I like Audacity because it shows us, we can zoom way in and see individual waveforms. So what I did in Audacity is I asked it to generate a sine wave for me, 30 seconds of a sine wave. It sounds like this. Okay, that's a sine wave. A sine wave is the most pure sound we can make. It has very few overtones, okay? It has the fundamental pitch that we ask it to make, and then above it, the overtones are almost none. And that's what makes it so just pure. Okay? If we zoom in and look at it, zoom way in, we're looking at fractions of milliseconds now. Okay? We see a sine wave. A sine wave is just a perfect flowing thing. Okay? It's the most simple sound we can create. However, it is super useful. We'll be using sine waves all the time. All right, let's select all and delete this. And I'm going to tell it to generate a square wave. This is another one of the most common waveforms. Okay, now a square wave has a lot of overtones, so it's going to sound more buzzy. The more buzzy something sounds, the more overtones it has. This is what a square wave sounds like. Okay, doesn't sound all that useful, but it is, trust me. If we zoom way in and look at a square wave, we can see that it's like a square. It goes up, flat, down, flat, up, flat, down, flat. It's just a square. It makes these squares all over the place. Now, the general rule is that the more right angles or the more sharp edges a sound has, the more overtones that it's going to create. It's just kind of a weird thing. I don't know the math or physics behind why that happens, but it happens. So in this case, this has these flat sides to it all over the place, which makes it very buzzy, which means it's going to have a lot of overtones. So just contrasting those two, one is really smooth and simple with no overtones or very close to it. The other is buzzy and a lot of overtones. Just with those two, we can make a lot of sounds by just combining them and then using some other tools that we have in synthesis to shape them. But let's learn about a couple more. Let's go select all and delete and go to generate, tone, and sawtooth. Okay, a sawtooth, I think we just saw a sawtooth. Sawtooth looks like this. Let's zoom way in. It looks like the teeth of a saw, right? So it goes up and then straight down almost, and then up, straight down. Now you can see this has some sharp angles in it, and that means it's going to be a bit buzzy. But it's differently buzzy, right? You hear the difference between that and a square wave. That's timbre. That's that buzziness. That's the overtones. They sound different. These have all been playing the same pitch. Okay, sine waves, square waves, sawtooth waves. the thing that makes them sound different is the overtones generated above them, and the overtones are generated because of the shape of the waveform. Okay? Now there's one more that for some reason just isn't built into Audacity easily, and that is the triangle wave. Triangle wave is a lot like a sawtooth wave, except instead of a flat side, it has a side that comes down similarly. So if we go here, here are, oh, this one doesn't have a triangle wave either. Interesting. The different shapes in analog. I have sine wave. I have sawtooth. I have square. And I have this one, which is noise. Right? We'll talk more about noise later. So this one doesn't have triangle, and Audacity doesn't have triangle, but triangle wave is one of the kind of what I consider to be the four most standard wave forms. But not everything has all of them. Every synthesizer is unique in that way, but they're always going to let you dial up something. Triangle wave, it has a similar sound to a sawtooth wave. Okay, so no matter what synthesizer you are working on, you will be able to find an oscillator section, and you will be able to select some sort of waveform. You're probably going to see sine wave, sawtooth wave, square wave, maybe triangle wave, and then maybe a handful of other unique things. So whenever you encounter a new synthesizer, just walk up to it, and your first question should be, where's the oscillator section? Okay, the second big section of any synthesizer is going to be the filters. Okay, so find the filter section. In our analog instrument here, it is this right here. Okay, so this says filter 1. There's also a filter 2 down here that's currently off. So filter 1. Okay, we're always going to have two controls. Well, not always. Not all synthesizers have two controls, but most of the time we should have two controls on our filter and one kind of drop-down menu with a few options. Okay, so let's talk about these options first. Okay, so what does a filter do? A filter is the main tool we have to carve away sound. It's going to filter out certain sounds. Okay, so we have to tell it what kinds of behavior we want it to have so that it can filter out the sounds that we don't want. And here we can see in this list several different kinds of filters that can be used. Low pass, band pass, notch, high pass, informant. Okay? So let's start with low pass. Now, in order to show you what this filter does, I'm going to pull up something different. I'm going to pull up an audio effect that I can show a filter in a much easier to understand way. So here's EQ8. Okay, I'm going to make this nice and big for us. We'll talk about these filters later. I'm going to turn these off. So we're just looking at one of them. Okay, and let's set up a low pass filter. Okay, so here's what a low pass filter does. In order to read this grid, here's what you need to know. Low sounds are on this side and high sounds are on this side. So low frequencies and high frequencies, okay? Low stuff, high stuff. And then in the middle, we have a 0, and then we have 6, 12, and then under that, -6 and -12. So this blue line, when it's on 0, that means we are doing nothing to the volume. But when I go up, now we are boosting the volume. And when I go under that 0, we are cutting that volume. Okay? So if I do this, what it means is that we're not going to do anything to the volume on this low stuff, but once we get up to right around here, we're going to start decreasing the volume of the higher stuff from, here's 1K, so from a little before 1K all the way to a little bit after 1K, all right? So we're going to reduce the volume of those frequencies as they get louder, and then anything above this point, we're just going to mute out. We're not going to listen to it. Okay, so this is called a low pass filter because it lets the low frequencies pass through it, not the high frequencies. If we want a high pass filter, we want this. It's going to let the high frequencies pass through it and get rid of the low frequencies. Okay? So going back to our filter in analog, we have a few different choices here. So low pass 12 and low pass 24. Okay, so let's go back to a low pass. Low pass 12 is going to look something like this. Oops, that's not a low pass. Here we go. Low pass 12 is going to look something like this. The number has to do with how steep this line is. Okay? So if that's 12, 24 is going to look something like this. It's going to be steeper. Okay? The number technically is decibels per octave, but you can just think of it as how steep this line is. Okay, so that's low pass and high pass. Band pass would be something like this, where we have just a single area that we're letting pass through. And then notch would be something like this, where we're kind of notching out some area. So in this case, we're not going to hear these frequencies in here, and these ones are going to be awfully quiet. Okay? So let's go back to analog. So if I say low pass 12, and you have to kind of imagine this filter shape in analog, because analog doesn't show you what that filter is actually looking like. So that's why I'm using this EQ out here so that you can kind of help you visualize what this is doing. We don't need to use this for sound purposes. I'm just using it to show you what it looks like. Okay, and then frequency, okay? Frequency is going to be also known as the cutoff frequency. That means where does this start to slope down, okay? So we can adjust that. And then resonance. Resonance means give it a little kick at the top, is the way I think about it. So resonance is going to be something like this. Okay, this means it's going to boost a little bit right at the top. Right before it starts to cut away, it's going to boost it. It makes like kind of like a laser gun effect. I'll show you in a second. Okay, so let's get rid of this EQ, and then let's just hear this. Okay, so let's move around my frequency. So remember, we have a low pass here. So as I move the frequency around, we're letting different amounts of high frequencies come through or get cut out. Right, so now the high frequencies are getting cut out, and we're left just with the low stuff. Okay, if I take resonance all the way down, we're letting more high frequencies come through. Okay, now let's give it some more resonance so you can hear what resonance does. This gives it that kind of laser gun sound. So if I do that same thing without resonance. Okay, so resonance can be fun. It can be a sound. It's an effect that you may or may not use. Okay, then the only other thing here in our filter section right now is this to filter to. This is unique to analog. It's going to let us send the signal after this filter down to our second filter so we can do a little bit of routing. We'll talk through that shortly. That's not something you always see in a filter section. Okay, so we have the oscillator section, we have the filter section. Now up next is the envelopes, and this one works a little bit different. So remember a little while ago, I said the three main elements that we need to focus on to create sounds are timbre, shape, and motion, right? So with timbre, we're primarily talking about the oscillator section. Okay, that's what's really going to control our timbre. The filter section as well is going to contribute to our timbre a lot. The envelopes are what really controls the shape, amongst other things. So envelopes are not necessarily a section, but they are scattered throughout most synthesizers in various ways. So you can see one right here. This is what they look like. Okay, if I click on the oscillator section, this is one as well. This is a little bit different looking one, but this is still an envelope. Filter, this is an envelope. Amplifier, this is an envelope. Okay, they are all over the place. This little graphic is the envelope. We can get access to its parameters over here, but you'll get really used to seeing this little graphic. In fact, Ableton likes to do it a little bit different. If you're looking at any other synth, you might see it looking more like this. This is the more traditional thing. Like if you drew this little picture and said, what is that? Most experienced sound designers or producers are immediately going to say envelope. The other thing they might say is ADSR, which I'll talk about in just a second. So what does an envelope do? Well, let's play with this one, for example. So this is in our amplifier. So this is going to be a volume envelope. We can apply envelopes to do a whole bunch of different stuff. What they do is give us certain points that we can apply to different parameters. With the volume envelope, we can say, how fast does this sound start? Does it start right away? In which case, this point is going to be, this line is going to be straight up and down. Okay, that starts right away. Do I not want it to start right away? Do I want it to fade in? Then we do that. Now it fades in. So now we're already just giving this a lot of shape just by doing that one thing. Okay? How do we want this sound to end? Do we want it to fade out? In which case it is. So I'll show you when I'm lifting up my finger right now. Right? It's got a quick fade to it. Let's make that fade longer. Here's our note. Now I'm going to lift up my finger. Very slow fade out. Come on. Okay, long fade out. What if I wanted to just stop? The second I pull my finger up, just stop. Okay, here's my finger. Just stops. And there's some other points here, and I'll talk about those in just a second. So with this, I can make a pad kind of sound if I do a slow attack and a slow release. Now I've got like a right, like more of a pad sound. Or if I do it with a quick attack and quick release, I have more of a lead sound. Ignore the weird glissing. That's my weird rolly keyboard. It's kind of strange sometimes. But let's go here. We can have a filter envelope, right? So with this envelope, we could say, I want my filter frequency to open over time and close over time, right? Now listen. You hear that go boing? That filter opens up over a minute. Over, well, half a second or so. In fact, 835 milliseconds. That's the actual amount. Okay, I can make that go slower. Slowly opening that filter. So now we're giving our sound even more shape. The two most common are amplitude, which is like the volume, which really gives it shape, and filter, which contributes to motion in the sound. Okay, so now let's talk about this graph a little bit more and talk specifically about this ADSR thing. Okay, this little graph is called an ADSR envelope. Okay, an ADSR, those 4 letters match to the 4 points. This line is our A, this line is our D, this line is our S, and this line is our R. Okay, here's what they stand for. Attack. Okay, the attack line, if that's straight up and down, then we have an instant attack. If it's on an angle, then we're going to have a slower attack, right? And so that can be straight up and down or varying degrees, okay? We can also control the attack right here. We can say, you know, we want a very slow attack, 15-second long attack. That's insane. Or a very near instant attack. Okay, so the first parameter is the attack. Now the second parameter is the D, ADSR. The D stands for decay. How fast does that initial sound decay? Now, in order to visualize this, think about like hitting a cymbal, okay, like a crash cymbal, going on a crash cymbal. So you're going to hit that thing with a stick. So the attack is going to be instant. As soon as you hit it, it's just bang, loud, okay? The actual hitting of the cymbal with the stick is very loud. But once you're done with the actual contact of the wood to the cymbal, then that cymbal is going to ring at a volume that is lower than it was when you actually were hitting it, right? So that's what this decay is. This is the amount of time and the amount of distance it takes to get down to that sustain level. Okay? Let me show you a couple examples of this. If I do this, what's going to happen is we're going to get a sudden sound because of that attack. And then very quickly, actually, let's make that less quick. The sound is going to decay to almost nothing. And then it's going to sit here on the sustain part. Okay, so you're going to hear the sound go up and down and then sit to where it's at its sustain moment. Okay, let's do that a little bit faster. Actually, let's do the decay a little slower. Oops, we're still on filter envelope. Okay, so we can hear the filter going open and close kind of fast. Okay, let's go back to our volume envelope where it's a little easier to hear. Let's just open up our filter envelope and go to our volume. Okay, so now here, we're going to hear that sound go up and then down quickly. Okay, that was that blip. That blip you heard was this. Let's make that blip a little bit longer. Okay, let's make our sustain a little bit louder. Okay, so now you can hear the volume go up and then come down and then get to a sustain point. Okay, now we're at the sustain point. That's our third thing, the S of ADSR, sustain. Okay, the sustain one works a little bit different because it's not a matter of time, where these other ones are about time. Attack is about how fast that sound gets in. Decay is about how fast that sound goes down to its sustain point. The S, the sustain, is about a level. Okay, so this is about a level, like how loud is it going to be while we're just sitting on the note. Okay, it's just going to be there forever. So if I go like this, then we're going to have a initial decay, and then we're going to sit on a volume that's almost the same as where it was. In fact, we can get rid of the decay completely by just doing this, and now we're just at full blast the whole time, right? That's not very interesting sound, although it does have its uses. So where this line is, this is going to be a loud sustain and a no sustain, quiet sustain, medium sustain. So the S is the volume at which it's just going to sustain at forever. But the end of the sustain is this point right here. This point is created when I lift my finger off the note. Okay, so this is letting go of the note, is that point right there. We can't control that point here because that point is controlled by when I lift up my finger or when I tell the MIDI note to stop playing. But as soon as I do that, this happens. And this is the R, which stands for release. So when I release the note, does it immediately stop? Does it fade out slowly? Does it fade out really slowly? Okay. So now we can craft a sound with some shape to it in a way that we want. Okay, and I let go, and that's what happens. Okay, so that's how envelopes work. You'll see this ADSR stuff all over the place. Sometimes you'll just see 4 knobs, and they'll just say A, D, S, and R, and you'll just kind of have to know how those work. We can adjust them here, A, D, S, and R. We have this sustained time, which doesn't really apply to us right now. ADSR envelopes are a crucial part of synthesis, so get used to seeing them and understanding the 4 different points that they're dealing with there. Okay, last but not least, the 4th main element of any synthesizer is the amplifier. Okay, amplifier is the simplest one. We will have an envelope in the amplifier to control the volume. We'll also have our main level, because we got to give it some juice, and probably panning is in there as well. Panning is your left and right balance. So all the way left, sounds like that. All the way right, sounds like that. If that sounded the same to you, then this video might have had its panning removed, which happens on some platforms. It's weird. I don't know why they do that, but whatever. So that's the amplifier section. Now, any synthesizer is going to have those 4 sections somewhere in it, and then probably some bells and whistles. Things like LFOs, unison, glide. That's kind of it for this one. So we'll talk about those as they come up, but those are the 4 sections. So as we go on and start learning the different live instruments, I'm going to do it by saying, okay, let's look at a new instrument and say, okay, where is our oscillator section? And we're going to find it, and we're going to learn how it works. And then we're going to say, where's our filters? Here they are. Where is our amplifier? Here it is. And if you understand those 4 sections, learning any synthesizer is going to be 1,000 times easier. Trust me.